Hi everybody, this week's video is going to be an overview of the anatomical structures of the eyes and ears. Start first with the eyes. This is the lacrimal duct. This is the lacrimal sac, just this top little bulb section here. This is the lacrimal duct, and this is the lacrimal canaliculi. So the gland, the sac, the duct, and the canaliculi. And canaliculi just basically means a small canal. So these structures here, the duct and the sac and the canaliculi, are to drain fluid. And then this here, this little pink part, is called the caruncle, in case you were wondering. Next is the muscles of the eye. We have the medial rectus, lateral rectus, and with this here, the superior rectus removed, we can see the optic nerve here, and then as well as the superior oblique. From the anterior view, all of you will see of the superior oblique is just the connective tissue that connects it to the front of the eye here. So if that's highlighted from the anterior view, you know you're looking at the superior oblique. And then down here we have highlighted the inferior oblique. And then the trick between knowing if it's the medial rectus or lateral rectus, because you could say, oh, well, that's lateral because it's on the outside of the skull. But you want to, it won't show the whole skull, but if you look at the clues here, you can see this is like the cheekbone right there. And then these are all the structures that we talked about in this picture that help drain fluid from the eye. So that's a clue to let you know that this is the medial rectus. Chambers of the eye. We have the anterior chamber between the cornea and the iris, and then the posterior chamber between the iris and the suspensory ligaments, and those are filled with aqueous humor. It's just the fluid that is filled with it to keep it in shape, or to keep its shape. And then this here is the vitreous chamber, just this whole back section of your eye, and that is filled with vitreous humor. Next is the ciliary body, which consists of suspensory ligaments and ciliary muscle. So the ciliary muscle is actually just a ring of muscles here. And this graphic is great because it shows what happens as the ciliary muscles relax. They pull back on these suspensory ligaments, which flattens out the lens. But then as the ciliary muscles contract, they reduce the tension on the suspensory ligaments. And so the lens isn't pulled anymore and it pops up into more of a bubble shape, gets rounder. The choroid, this is just a quick picture. It's just this membrane between the retina and the sclera, and then the sclera is all this white part. It's just that really fibrous connective tissue that covers the eye. It's a super great protective layer. If you've ever been in a science class and done like a dissection of a cow eye, you notice that this is the part that's really hard to cut through. The ora serrata is just where the retina and the ciliary body connect, just to keep the ciliary body in place, and they named it ora serrata because it kind of has a serrated appearance where those two join together. Next is the macula lutea, the fovea centralis, or central fovea, whichever of those terms you like, it doesn't matter, and then the optic disc. So the macula lutea is right here, with the very center right there being the fovea centralis, and then just this bump here where it comes up like that is the macula lutea. And then the optic disc kind of looks similar, so be careful not to mix these structures up. But the biggest difference that the optic disc is connected to the optic nerve. So it's at the very start of the optic nerve, which will go out of the eye into the brain. So pay attention to that, the difference in those. If you've ever been to the eye doctor, you've probably seen a picture like this. So this is just a picture of what it looks like in a real eye. This here, the light section, is the optic disc, and the dark section is the macula lutea, at the very center of that being the fovea centralis. Here's just a zoomed in picture or animation of the optic nerve. You'll see here just these vessels here that supply blood to the retina or to the eye. And then you'll notice that the retina actually connects with the optic nerve and becomes the optic nerve so that it can transmit signals from the light you're seeing onto the retina and to the optic nerve. Moving on to the ear now. So the biggest mistake I've seen with the ear is the mix-up between the eustachian tube and the external auditory meatus. Whatever you have to do to keep those two names straight is awesome. Just go for that. and just really make sure you don't get these two mixed up because that happens a lot with people. My advice would just to be keep it simple, eustachian tube, and external auditory meatus. If you call it the acoustic meatus or the auditory meatus, then you get confused with auditory tube. So just pick one name, make sure they sound different enough that you won't get them mixed up. So this here is the eustachian tube, and this is the external auditory meatus. And the external auditory meatus is what you can see when you look in a person's ear. It's what you clean out with Q-tips. This right here is the tympanic membrane, and then we see the ear bones and the cochlea sticking up right there, and these are the semicircular canals. A couple ear muscles. We have the stapedius muscle. It's actually the smallest muscle in the body. It attaches to the stapes and then to a process on the temporal bone just to keep the stapes in place so it doesn't move. And then the next one would be the tensor tympani, which just connects to the malleus here. And then just a zoomed in view of the inner ear, we have the tympanic membrane, or the middle ear, excuse me. We have a zoomed in view of the tympanic membrane, the ear bones, and then the stapes here, which hits against the oval window or the fenestra vestibuli. And that's what sends waves through the fluid in your cochlea and gets deciphered into sound. And then down here we have the round window or the fenestra cochlea. You can either call it the fenestra cochlea or the round window, or you can call it the oval window, or you can call this one the oval window or the fenestra vestibuli. Either of those answers will be accepted. Over here is just a picture of it. You can kind of see the difference in shape here, just that the round window is much smaller and more round, and the oval window is bigger and has an oval shape. Here are the semicircular canals. What's highlighted here, the ampullae. We have the superior semicircular canal, the posterior semicircular canal, and the lateral semicircular canal. Be careful when studying these. Don't jump to conclusions and think, oh, that's lateral because it's lateral in the picture I'm looking at. You want to make sure that even when you're looking at it from different viewpoints, you remember which one's which. So this here's the posterior semicircular canal. This is the superior, and this is the lateral. So zooming in now to the cochlea, the structures within the cochlea, we have the scala vestibuli, and the scala tympani down here, and the scala media right here, this space. And then this membrane here is called the vestibular membrane. If we zoom in even further, we can see the organ of Corti, C-O-R-T-I, which is just where these hair cells come from. So those are hair cells highlighted right there. And this is the tectorial membrane. And this layer right here, the lighter color, is the basilar membrane. All right, I think that's it. Happy studying and good luck.